Hi, I'm Professor Sophia Domokos from the New York Institute of Technology, and I'm here to tell you about the origins of string theory. Now, you might have heard about string theory before, possibly in the context of being a theory of everything. That is a theory that explains all of the forces in our known universe. You might not know that string theory has given rise to a whole bunch of really fascinating ideas, including one called holographic duality, that claims there is a relationship between crazy objects like black holes and materials right here in this world. But we're not going to get into all of that today. Today, we are going to talk about the origins of string theory. Where did this idea come from? So the basic idea in string theory is that instead of having every single elementary object, the tiniest objects you can have, be a little tiny point, that's what we usually assume, the idea was, what if those objects instead are little teeny tiny vibrating strings? Now, where did this idea come from? Well, we can trace the origins of string theory all the way back to the 1950s and 60s, when people were observing a whole bunch of new particles, which they collectively called hadrons. Now, you might be familiar with some hadrons. Those are the protons and neutrons on the inside of every atomic nucleus. But there were a whole bunch of other ones. And people started to wonder, if there are so many types of particles like this, maybe there's a way we can describe them that's more fundamental, more elegant, and will help us learn more about the universe and physics in the end. Now, to understand why you might want to do that, let's rewind even further and talk a little about the periodic table of elements. Now, the periodic table is just a listing of all of the elements that we know about. Okay, this table was first written down in the 1800s by a guy called Dmitri Mendeleev. And basically what he was doing was organizing these materials that we knew about in terms of patterns of their behavior. For example, all the way over on the right-hand side of the periodic table are the noble gases. Those are gases that don't interact very much. And eventually, after studying this table and other developments in physics, the idea came along that explained why these patterns exist, and in fact described the structure of every single one of these elements as an atom that has an atomic nucleus with protons and neutrons inside and electrons orbiting around it. And the number of these electrons, and whether or not they're what we call valence electrons, were the thing that helped to understand or helped to explain these patterns. The idea with hadrons was that people wanted to do something similar. People were observing so many different types of hadrons that they began to wonder if they could see some patterns in all of these different varieties, kind of like the periodic table. They noticed a bunch of patterns, and one of them was a pattern called a Regge trajectory. What they saw, that for each light hadron that wasn't super heavy, there were exact copies of that same type of particle, just heavier and heavier and heavier versions. Another thing they observed was that there was a relationship between the spin of the hadron, the spin being kind of like a type of internal rotation, and the mass. So they would see the same light hadron, which had a small spin, and then they would see versions of that hadron with higher masses and higher spins. Now, this is where string theory comes in. So let's say all of the most basic objects, all of the elementary objects in your universe are little tiny vibrating strings. Now, first of all, does that make a difference in the physics you know? Well, the answer is that it doesn't if you make those strings small enough. Because if a string is really, really tiny and you're far enough away, or you don't look at it closely enough, you don't look at it at a very small scale, you won't be able to tell the difference. It'll just look like a point particle to you. So then how does it help us to make our objects these little tiny vibrating strings? Well, the answer actually comes from a very old equation, E equals mc squared due to Einstein. Now, what this equation says is that mass is just a form of energy, right? There's energy of motion, kinetic energy, and then there's also this other form of energy called mass energy, which an object has just because it's massive. But the fascinating thing about this equation is that it also goes the other way, that you can think of energy as a form of mass. So this leads us to one way that string theory can help us understand the masses of the hadrons. Because let's say you've got a little string and it's not vibrating too fast. Then it doesn't have a lot of kinetic energy, which means when you're looking at it from far away and you see it as a point particle, you say, okay, it doesn't have a very big mass. But now if you take that exact same type of string and get it vibrating faster, from far away, you're going to see a particle that's much heavier. So that's one pattern we saw in this hadron spectrum. Now the other pattern we saw, called regitrajectories, that related the spin of the particles to their mass, is a little bit more mysterious, but you can also describe it with little tiny vibrating strings. So let's look at our little string again. And this time, let's set it rotating around. The faster it rotates, the more kinetic energy it will have, and the higher spin, or higher angular momentum, it has. So this idea also explains the regitrajectories, the relationship between the mass and the spin of the hadron particles. So that's why string theory was originally proposed as a way to think about hadron objects, which include the protons and the neutrons in the atomic nucleus. Now later on, another idea came along called QCD, which helped solve a bunch of issues with this original form of string theory. But the idea of string theory persisted, and it turned out to be one which was very, very useful and very revolutionary in the way that we think about physical theories. We're going to talk about that more in later videos. So in this video, we learned about the origins of string theory, about how it came about in the 1950s and 60s as a way to explain the behavior of these particles called hadrons, which include protons and neutrons. We also understood how string theory can explain patterns you see in the masses of these hadrons. And we also saw how Einstein's equation, E equals mc squared, relates mass to energy. That's all for today. See you in a later video.